Robotics-IV, class of 2001 group, and we're going to demonstrate our final project here. We made a ball bearing maze game, which is milled into the WCC logo with the WCC colors, and we use plexiglass. My name is Eric Ruby, and I'm also going to introduce Hugo Okogure, who couldn't make it with us tonight.
I'm Vernon Rowland.
I'm Ed Grabo.
Okay, the first part of our project was to use a conveyor here, where our operator is going to load 3 individual pieces of plexiglass. After the operator loads those 3 pieces of plexiglass, they're going to hit our start buttons here, incorporated into our cell. From here, we move on to our 8010 DeVillibus cylindrical robot, which is going to take those pieces of plexiglass one at a time, load them into a CNC machine, which is going to mill into our design.
From there, it's going to take it to the Puma 760, which is going to glue the 3 pieces together and put the ball bearings in it.
Okay, after the 760 glues the parts together, the robot's going to load the part back onto our pallet, which will return back to our operator where they can unload the game and distribute them to whoever they want to. We also incorporated light curtains for safety, so if these light curtains are ever broke, our cell will shut down. We have an e-stop circuit that can be hit to also stop our cell in the event of emergency.
The operator has to load the parts. When the pallet is positioned and we get the operator ready light, the operator is allowed to break the light curtain. Load the parts into position. Then he steps back out of the light curtain, presses both start buttons at the same time. You have to make sure the cell is in auto. The 8010 then comes over and gets the first part, which will be the maze part of the game, and puts it into the CNC machine. Because we have 2 robots in this cell, we can run them simultaneously.
Okay, right now we got our first piece of plastic loaded into the machine. We do this in 2 stages on the CNC machine. We're going to first do our maze here. Right now it's just began cutting the grooves in, and previously it drilled all the holes for the ball return. As this is cutting the grooves into the plastic, we have coolant spraying on there so our cutting tools don't gum up with plastic. This gives us a better product in the end. Okay, once the first part's complete and it's machining, we will machine a second part here, and this is the ball return. We're just going to cut a couple grooves in here, so once the 3 pieces are assembled at the later assembly station, we'll actually have a working maze here. And then we cover that with just a clear piece that's unmachined. This, like I said, this will be completely glued together at a later station. here our robot is dipping our part in methylene chloride, which reacts only with the plastic and not the metal ball bearings. Right here our robot is picking up the ball return, which will be moved over to the ball bearing insertion station. Here it's going to insert a 5/32 ball bearing twice, and it does this at the same time to minimize cycle time. Right now we just did the final assembly where we glued all 3 pieces of the preloaded plexiglass together. The robot will eventually take this back to the pallet where it will return to the operator. Concludes our presentation of our